Here you can see cargo compartment classified in 4 categories. The first one is class A, second one is class B, third one is class C, and fourth one is class E. So the first one is class A. A class A cargo or baggage compartment is one in which the presence of fire would be easily discovered by a crew member while at his or her station, and each part of the compartment is easily accessible in flight. And class B, a class B cargo or baggage compartment is one in which there is sufficient access in the flight to enable a crew member to effectively reach at any point or any part of the compartment with the contents of a hand fire extinguisher when the access provisions are being used. No hazardous quantity of smoke, flames or extinguishing agent enters any compartment occupied by the crew or passenger. And the class C is a class C or baggage compartment is one not meeting the requirement for either class A or B compartment, but in which there is a separate approved smoke detector or fire detector system to give warning at the pilot or flight engineer's station. There is an approved building in fire extinguishers or suppression system controllable from the cockpit. There are means to exclude hazardous quantities of smoke, flames or extinguishing agent from any compartment occupied by the crew or passenger. The class E cargo compartment is one on airplanes used only for the carriage of cargo and in which there is a separate approved smoke or fire detector system to give warning to the pilot or flight engineer station. The controls for shutting of the ventilating airflow to or within the compartment are accessible to the flight crew in the crew compartment. There are means to exclude hazardous quantities of smoke, flames or noxious gases from the flight crew compartment. This is all about the classes of cargo compartment. So the next one is fire detection and extinguisher system in cargo. Now the smoke detector system in cargo aircraft. The optical smoke detectors consist of a source light emitting diodes, intensity monitor photodiodes and scatter detectors photodiodes. Inside the smoke detection chamber, air flows between a source and a scatter detector's photodiode. Usually only a small amount of light from the LED gets to the scatter detectors. If the air has smoke in it, the smoke particles reflect more light on the scatter detectors. This causes an alarm signal. The intensity monitor photodiode makes sure that the source LED is on and keeps the output of the source LED constant. This configuration also finds contamination of the LED and photodiodes. A defective diodes or contamination causes the detectors to change to the other set of diodes. The detector sends a fault message. The next one is cargo compartment extinguishing system. The cargo compartment extinguishing system is activated by the flight crew if the smoke detectors detects smoke in the cargo compartments. Some aircraft are outfitted with two types of fire extinguisher containers. The first system is the dump system that releases the extinguishing agent directly when the cargo fire discharge switch is activated. This action extinguishes the fire. So the next one is lavatory. As we discuss smoke detector system, cargo compartment extinguishing system we are also discussed. So the next one is lavatory smoke detectors system. In airplanes that have a passenger capacity of 20 or more, are equipped with smoke detector system that monitors the lavatories for smoke. Smoke indication provide a warning light in the cockpit or provide a warning light or audible warning at the lavatory and the flight attendant station. Warning at the lavatory that would be readily detected by a flight attendant. Each lavatory. Now the lavatory smoke detector system. The lavatory smoke detectors is powered by the 28-volt DC left main DC bus. If there is a smoke in the sensing chamber of the smoke detectors, the alarm LED comes on. The timing circuit makes an intermittent ground. The warning horn and lavatory call light operates intermittently. The smoke detection circuits makes a ground for the relay. The energized relay makes a ground signal for the overhead electronic unit, which is called OEU. In the central monitoring system, this interfaces gives this indication lavatory master call light flashes, cabin system control panel and cabin area control panel pop-up window shows, and the lavatory call chime operates. Push the lavatory call reset switch or the smoke detectors interrupts switch to cancel the smoke indication. If there is still smoke in the lavatory, the alarm LED stays on. All smoke indication go away automatically when the smoke is gone. This is all about the lavatory smoke detector system. Now the lavatory fire extinguisher system. As you can see in the image, the lavatory compartment is outfitted with a fire extinguisher bottle. Here is the fire extinguisher bottles installed. Fires in the waste compartment. The fire extinguisher is a bottle with two nozzles. The bottle contains pressurized halon 1301 or equivalent fire extinguishing agent. When the temperature in the waste compartment reaches approximately 170 degrees Fahrenheit, the solder that seals the nozzle melts and halon is discharged. Weighing the bottle is often the only way to determine if the bottle is empty or full. So the next one is fire detection maintenance system. In fire detection and maintenance system, we should check all the parts of the cargo where the fire extinguisher system and detection system is installed. So the fire detection sensing element are located in mainly high activities areas around aircraft engine. Their location together with their small size increases the chances of damage to the sensing element during maintenance. An inspection and maintenance program for all types of continuous loop system should include the following visual checks. These procedures are example and should not be used to replace the applicable manufacturer instruction. We should check. First one is cracked or broken section caused by crushing or squeezing between inspection plates, cowl panels or engine component. The second one is abrasion caused by rubbing of the element on cowling, accessories or structural members, pieces of safety wire or other metal particles that may short the spot detectors. The fourth one is condition of the rubber grommets in mounting clamps that may be softened from the exposure to oils or hardened from excessive heat. This is all we should inspect during the examination and maintenance. Next one is fire detection system troubleshooting. The following troubleshooting procedure represent the most common difficulties encountered in the engine fire detection system. The first one is intermittent alarm are most caused by an intermittent short in the detector system wiring. Such short may be caused by loose wire that occasionally touches a nearby terminal or thread wire brushing against a structure or a sensing element rubbing against a structure member long enough to wear off cartridge through the insulation. Intermittent faults often can be located by moving wires to recreate the short. The second one is fire alarm. Fire alarm and warning lights can occur when no engine fire or overheat condition exists. Such false alarm can be most easily located by disconnecting the engine sensing loop connection from the control unit. If the false alarm ceases when the engine sensing loop is disconnected, the fault is in disconnected sensing loop, which should be examined for areas that have been into contact with hot parts of the engine. And the third one is moisture. Moisture in the detection system seldom causes a false fire alarm. If however moisture does cause an alarm, the warning persists until the contamination is removed or boils away and the resistance of the loop returns to its normal value. The next one is kinks and sharp bends. Kinks and sharp bends in the sensing element can cause an internal wire to shortly intermittently to the outer tubing. The fault can be located by checking the sensing element with an ohm meter while tapping the element in the suspected areas to produce the short. So the next one is fire extinguisher system maintenance. The first one is container pressure, and the second one is discharge cartridge, third one is agent container. So the first one is container pressure check. Regular maintenance of fire extinguisher system typically includes such items of inspection and servicing of fire extinguisher bottles, removal and reinstallation. Discharge cartridge. Container pressure should be checked periodically to determine that the pressure in between prescribed minimum and maximum limit. Changes of pressure with the ambient temperature must also fall within the prescribed limit. The second one is discharge cartridge. The service life of fire extinguishers discharge cartridge is calculated from the manufacturer date stamp, which is usually placed on the face of the cartridge. The cartridge service life recommended by the manufacturer is usually in the terms of year. Cartridges are available with a service life of 5 years or more. The next one is agent container. Care must be taken in the replacement of cartridge and the discharge valve. Most new extinguisher containers are supplied with their cartridge and discharge valve disassembled. Before installation on the aircraft, the cartridge must be assembled properly in the discharge valve and the valve connected to the container, usually by means of swivel nut that tightens against a packaging ring gasket. If a cartridge is removed from a discharge valve for any reason, it should not be used in another discharge valve assembly, since the distance of the contact point produces may vary with each unit. Thus, continuity might not exist if a used plug that had been intended with a long contact point were installed in a discharge valve with a shorter contact point. So the next one is fire prevention. As we all know that fire prevention is most useful as compared to fire protection. So in fire prevention, including leaking fuels, hydraulics, dissing or lubricating fluids can be sources of fire in an aircraft. This condition should be noted and corrective action taken when inspecting aircraft system. Minute pressure leaks of these fluids are particularly dangerous, for they quickly produces an explosive atmosphere condition. Carefully inspect fuel tank installation for signs of external leaks with integral fuel tanks. The external evidence may occur at some distance from where the fuel is actually escaping. Many hydraulic fluids are flammable and it should not be permitted to accumulate in the structure. Soundproofing and lagging materials may become highly flammable if soaked with oil of any kind. Any leakage or spillage of flammable fluid in the vicinity of the combustion heaters is a serious fire risk, particularly if any vapor is drawn into the fire heater and passes over the hot combustion chamber. Oxygen system must be kept absolutely free from traces of oil and grease. So thank you for watching. If you have any doubt in this video, you can put your doubt in comment box, and please like and share my channel.